Welcome. Let's continue with the topic optics, and today we are going to discuss about eye defects. In the previous lessons, we learned lenses and their types. We learned that we have converging lens which has a positive focal length, and we have a diverging lens which has a negative focal length. We also learned that the focal length may be positive or negative depending on two factors majorly. The first one is the radius or radii of curvature. The next one is the material in which the lens is made. So those are the two major factors that determine the nature of the focal length to either be positive or negative. Again, we learned that according to lens maker's equation, the focal length may be positive for a lens, but then when you surround the lens with a liquid of a certain refractive index, it is possible to have a focal length of the combined lens to be negative, meaning that the surrounding medium affects the nature of the focal length. So we go on and look at the terms that are used in this. We have the first one as the retina. So retina is the innermost light sensitive layer of the tissue of the eye. What the retina does is to change the light energy into electrical impulses that are sent to the brain for interpretation. If light comes from a tree, it will fall on your eye, and then your lens will converge it to the retina. That's where all the tasks are going to be done. That's the most important thing to note, that the image should always be formed at the retina. We have another one as the near point. Near point is the point nearest to the eye at which an object is accurately focused on the retina when the maximum degree of accommodation is employed. Accommodation is the ability of the eye to adjust the focal length in order to be able to see distant and nearby objects. So for the normal eye, the near point may be about 25 centimeters. So that's the point where you can place an object and you still see it clearly. But you can still see it clearly below 25 centimeters if you're reading notes from your book and you place your book close to your eye less than 25 centimeters. You may also see the notes clearly. But as you bring the book closer to your eye, you start straining your eye more and more and more. But at the near point, you don't need to strain your eye. You see the object clearly. The last concept that we want to look at here is the far point. So the far point is a farthest point at which an object can be seen distinctly or clearly by the eye. For a normal eye, the far point is infinity. You can see that, you can notice a car is coming clearly from a distance. You can see houses and trees, and you can see the moon, you can see the skies. When they are far, they are at infinity clearly because your eye is working well. If you ever happen to have a far point which is not infinity, which is just like maybe 100 centimeters or 200 centimeters, then your eye has a problem. Let's look at the first eye defect, and this is myopia, which is the same as short sight or near-sightedness. As the name sounds, you can see clearly objects which are near you, but those which are far away from you, you cannot see them clearly. What causes this? In our notes here, we see that for a normal eye, the image has to be formed at the retina, as we have seen before. But under this defect, the eyeball is too thick. That's one problem that we have. The eyeball is too thick. Another problem is that the lens is too strong. So if the lens is too strong, coming back to this diagram, we can see that the lens converges the rays and the image is formed here before the retina. The retina is somewhere here. Image is formed before the retina. So that's the biggest problem. Your lens is too strong, it converges so much the rays, or your whole eyeball is too thick. Let's see how we can correct myopia. We correct it using a diverging lens. So this diverging lens has a negative focal length. So what it does is, let's first remind ourselves of the problem that we are solving. Our lens is too strong, so it converges the rays so much that the image I1, the image is formed in this position before it reaches the retina, before rays reach the retina. So we must use a diverging lens which first diverges the rays, and then your beam, your natural lens, so let's say that's lens 1, natural lens 2, is going to converge them and then finally forms the image at the retina here. That's how we correct this defect. So the next one is hyperopia, which is long sight or far-sightedness. As the sound of the name, you can be able to see distant objects clearly, but those which are near you, below a certain distance, you cannot see them clearly. Let's look at the diagram. This lens is a converging lens. Converging lens has a positive focal length. The problem that we have here is the eyeball is too thin. Eyeball is too thin. So if it is too thin, it means that the rays are going to converge beyond the retina. So the image is going to be formed beyond the retina. The retina is here. Image is formed beyond the retina. So what does that mean? If our lens is too weak or the eyeball is too thin, that means we need to converge these rays twice. So your lens 2, lens 1 is an artificial lens and lens 2 is a natural lens. The artificial lens is a converging, so it's going to converge the rays first, and then they will meet lens 2, which is your natural lens, and then converge them again to form the final image here at the retina. With that, we would have solved the problem. So we use the lens, which is a converging lens placed in front of the natural lens. The last one here that we shall discuss today is astigmatism. Astigmatism is not the same as myopia, not the same as hyperopia, but combines the two. Here the rays of light do not focus at the retina. As we know, they should always focus at the retina. Where images must be formed, some parts of the rays are focused in front and other are formed behind. So we have both images formed in front of the retina and behind the retina. Therefore, it combines the two, and this can be solved using a cylindrical lens or can be solved using surgery. All these eye defects can be corrected using different eye lenses, but these lenses being different, I mean that they may be contact lenses or maybe lenses like the ones I'm putting on, or you may undergo a surgery and they plant in you a lens inside the eye.